Hey class, today I'm doing a lesson on compound probability. Compound events is combining two or more events using the word and or the word or. So you've seen this before. When we see the word and is when we multiply. When we see the word or is when we add. And statements can be independent or dependent. Or statements can be mutually exclusive or overlapping. And sometimes we see inclusive instead of overlapping. All right. So independent events occur of one event has no effect of the occurrence of the other. And sometimes we see it with this notation. Dependent events is the occurrence of one event affecting the occurrence of the other. And we see it with this notation with a slash, meaning it's affecting the other occurrence. So of course, when we see examples, this will make more sense. So let's do some examples together. This first one is about a quality inspector of a car manufacturer randomly selects one car from each batch of 50 cars to inspect for problems. The first batch of 50 cars has 4 cars with sticky gas pedals, and the second batch of 50 cars has 5 cars with the same problem. Find the probability that the inspector will select a car with a sticky gas pedal in the first batch and second batch. Okay, so things to recognize. It's an and statement, so we want to multiply. So the last sentence says, find the probability that the inspector will select a car with a sticky gas pedal in the first batch and the second batch. So that is our clue that we are multiplying. This situation is independent. Picking in the first batch will not affect the pick of the second batch. And that is important on your setup. Okay, so we have 4 out of 50 for our first batch that have sticky gas pedals. Then we are going to multiply because we see that word and. And then our second batch, we have 5 out of 50 that have sticky gas pedals. All right, we do not need a common denominator to multiply fractions. So we are multiplying straight across, giving us 20 over 2,500. And that does reduce to 1 out of 125. And that is a reduced fraction. So that could be an answer choice. Or we could change it to a decimal that changes to a percentage by moving the decimal 2 places to the right. And that would be 0.8%, very small percentage that we have the probability of selecting 2 problem cars. All right, so that is an independent event. Our denominator stayed the same. Second example, an aquarium contains 6 male goldfish and 4 female goldfish, which is a total of 10. You randomly select a fish from the tank. Do not replace it. And then randomly select a second fish. What is the probability that the first fish is a male and the second fish is a male? Okay, so we see that word and, so we know we are multiplying. This situation is dependent because you are selecting a fish, not replacing it, which changes the chances for the second draw. So that's going to affect our setup. All right, so the first time you select a fish, your chances of getting a male is 6 out of 10. And then we are going to multiply because we see that word and. But the second time we draw a fish out, we don't have 10 to choose from. We have 9 because we did not replace it. And then we do not have 6 males to choose from because we did not replace it. So we have to go down in numbers. So 6 out of 10 for the first draw, and since we did not replace it, we have 5 out of 9. Then we can multiply it straight across, which is going to give us 30 over 90, and that reduces to 1/3 as a reduced fraction. As a decimal, we get 0.33, which changes to 33%. Okay, so this is a dependent event. What happens with the first draw changes the outcome of the second draw, and that is why we went down in numbers. Okay? All right, now let's talk about mutually exclusive and overlapping events. Mutually exclusive events have no common outcomes. Two things can't be both true at the same time, and it has this notation. Overlapping, a common outcome, two things that can both happen at the same time, and this is our notation. See how they're separated here? No common outcome, put together right here as a common outcome. Notice that you're going to add together, because this is an or statement, but we never want to count the overlap twice, and that's why we have this subtraction right here. So let me show you some examples to help you understand. What is the probability that you choose a queen or an ace? It is an or statement, which means we are adding. It is mutually exclusive because you can pick a single card and it can be a queen and it cannot be a queen and it cannot be an ace at the same time. So I want to show you that on our deck of cards. So if I were to circle all of the queens, and if I were to circle all of the aces, there is no overlap. There are 4 queens and there are 4 aces. Okay, so our setup would be 4 out of 52 cards plus 4 out of 52 cards for the ace. This is a fraction that you're adding that already has a common denominator. So when you look at this, 52 is your denominator, you are adding to get 8 over 52, which reduces to 2 over 13. That is your reduced fraction. That's about 0.15, which changes to 15%. Okay? So this would be mutually exclusive. The outcomes cannot be the same. It cannot be a queen and it cannot be an ace at the same time. All right, the fourth example, what is the probability that you choose a king or a club? All right, so I want to show you with our cards. I'm going to circle in a different color. So if I'm going to circle all of my kings, there are 4 kings. Or a club. So I'm going to circle all of my clubs. So you can see the overlap is this king of clubs. So this is an overlapping event because you could get a king and you can get a club at the same time. Okay? So you want to set up your probability of getting a king, 4 out of 52. Your probability of getting a club, 13 out of 52. But I don't want to count that king of clubs twice. Here is a king of clubs, and here is a king of clubs. So I need to take out the overlap, which is that one card where you overlapped. So we have 16 over 52, which reduces to 4 over 13 as a reduced fraction. That's about 0.31, 31%. Okay, so for overlapping events, you always want to take out the overlap so you do not count it twice. I added this to the PowerPoint if you want to print this out. Of course, it doesn't print out in color unless you have color on your printer, but or just look at this visually on eClass. But this would be helpful to circle with these kind of events happening to see if there is an overlap, like I did with the King of Clubs, or mutually exclusive events in the yellow. There's no way you could get an ace and a queen at the same time. All right, well, y'all have some practice. It is called Practice with Compound Probability, and you'll have to submit your assignment on eClass. Feel free to email me with any questions. Thanks, guys.